Hi Rockridge, this is Mrs. Berger, and today we're going to be talking about solving rational equations. So up to this point in the unit, you were asked to simplify a rational expression, which was either multiplying, dividing, adding, or subtracting. Today we're going to make use of our lowest common denominator skills and solve some rational equations. So let's take a look at what we mean by these. When you see expressions like this with an equal sign in between, you should think, first thing I should do is factor the denominator if possible. I should also make sure that I don't have any no-nos in the denominator. I should always make sure that there's nothing in the denominator that can cause a zero in the denominator. So if I look here, there's no way to cause a zero here. There's no x in here that's a variable that could cause a zero. There's no zero here, and there's no zero here. So that's what we mean by check for restrictions on x. And then we need to find an LCD. We need to find a lowest common denominator, get every term, every expression up to that LCD, and then solve for x. So let's see what we mean by this. So first and foremost, restrictions. We don't have any here. There's no x's in the denominator that could possibly cause a division by zero. So we don't have any restrictions. If you look across the bottom here, the lowest common denominator for all of these would be 12. Okay, and so let's see what we would need to do to get all of these fractions up to a 12. So obviously this fraction already has the 12, so it doesn't need to be multiplied by anything. This fraction has a 4, so it needs to be multiplied by 3, and whatever we do to the bottom, we must do to the top. And this fraction has a 3 in the bottom, we need to multiply it by a 4, and whatever we do to the bottom, we must do to the top. So now we have 7x over 12 plus 3 times x plus 2 over 12 equals 4 times 2x minus 3 over 12. Now, if you've been through the warm-up with your teacher or taken a look at the paper for yourself, you remember that when you saw fractions like 1/2 plus 7/2, when we combine those, we would have 8/2, right? When we have that common denominator. Something interesting also happens if you have equations like this. If you have the common denominator, not only can you combine these two over that common denominator, but you can actually take the numerators and just solve the numerators. Since they're over this common denominator, you can turn this into a problem just based on the numerators. And remember, you could only do this after you get everybody up to that common denominator. But once you have everyone up to that common denominator, you can throw that thing away and solve the top. Okay? So that's what I did here. I threw the denominator away, and now I'll be solving the top. Oh, and I miswrote this. Sorry about that. There you go. All right, so let's do that. So 7x plus 3x plus 6 equals 8x minus 12. Okay, just distributed those. Now I'm going to get my like terms together. It looks like I have 10 x's over here and 8 x's over here. So I'll subtract 8x from both sides and just leave 2 x's here. It looks like I have 6 here and negative 12 here. I'll subtract 6 from both sides and get a negative 18 over here. Divide by 2 on both sides, and I have x equals negative 9. And I'm allowed to write this on my number line because up here in the restrictions I didn't say x couldn't be negative 9 because I would cause a division by 0. So we always need to check before we write our answer on this line. We need to check and make sure it doesn't break any rules up here. Okay? Alright, let's get a little more difficult with the next one. So once again, we need to figure out what our lowest common denominator is. And don't forget, this 7 is currently sitting over top of a 1. We also need to talk about restrictions. So let's look again. We have variables in the denominator here. We have variables in the denominator. So there's a possibility that x could be something that would cause a problem. And again, we're not allowed to have the denominators equal 0. So this here, x minus 2, you can't equal 0. Same thing again here, we don't need to write it again. And down here, we don't really have that possibility, right? There's no x down here, so we don't have a risk there. So this is my only risk that I need to take care of. Let's add 2 to both sides to state x cannot equal 2. Okay? So that's our restriction for this particular problem. So when we finish getting our LCD and solving, we hope that we don't have x equals 2 in our final. Now let's take a look at the LCD. We have an x minus 2, a 1, and an x minus 2. So it sounds like 1 times x minus 2 is our lowest common denominator for this. So let's get everybody up to par here. This one already has it, so we don't need to multiply by anything. This one is missing the x minus 2, so we need to multiply both top and bottom by x minus 2. And this fraction already has everything. So we've now got 5x over x minus 2 equals 7 times x minus 2 over x minus 2 plus 10 over x minus 2. Again, now that we have everyone over the common denominator, we can throw that away and just solve the top. 5x equals 7 times x minus 2 plus 10. That's now the equation that we'll be solving to find what x equals. Once again, let's distribute and combine like terms. I will subtract 7x from both sides to give me negative 2x over here, and I'll combine these to get negative 4. Divide by negative 2 on both sides, x equal 2. So I'm about to write x equal 2 on my answer line, but think for a minute, why am I not allowed to do that? Why can I not just circle this and say that's my answer? Because we had a restriction in this problem. X may not equal 2. 2 is a no-no here because that'll cause a division by 0. So since the only answer I got off this problem was x equal 2, I actually have no solution to this problem. There's no solution here. If I had any other number besides 2, I would be good to go for that answer. But since that was the one thing that we had a restriction on, we don't have a solution to this problem. Let's look at another couple. So again, key here is finding the lowest common denominator. If I look at all of these, hopefully you already see that the lowest common denominator for all 3 of these fractions is 3x. So we're going to need to bring everybody up to a 3x for the denominator. Restrictions. What can x not be? Well, we don't have anything going on here that would cause a problem. But there are possible values here on the bottom of these fractions. If x itself was 0, that would be a problem. So we'll state x, you may not equal 0. And we're going to try solving this, and hopefully we don't end up with x equals 0 as our only answer. So let's see. First fraction, what is it missing? Out of the LCD, it's missing a 3. So we'll need to multiply 3 over 3 to get that one up to speed. This fraction is missing the x. This fraction, again, we've got somebody missing the 3. So now that I've got everybody with the red up to speed, up to 3x on the bottom, I'm not even going to bother writing that bottom just to save paper space. So now let's look at what we have on the top here. We have 3 times 2, that's 6, plus 5x equals 7 times 3, that's 21. Subtract 6 from both sides. Divide by 5 on both sides. So I claim that x equals 3. Let me real quick check against my restrictions. X cannot equal 0. Well, that's not what I got, so I'm okay to write x equals 3 on the answer line. Alright, let's take a look at the next one. We definitely, if you go back to our little steps, we need to make sure that we factor everything so we have a nice clear picture of what's going on the bottoms of these fractions. So this can't be factored, that's not the problem. But this guy right here, so that I can get a clear picture of what we have in the common denominators here, we need to factor this. This is a difference of squares, so it needs to be x plus 1 and x minus 1. Let's see, what is our lowest common denominator across the bottom here? Definitely x plus 1 needs to be accounted for. This fraction throws x minus 1 into the mix, so we need to account for that. And this fraction just has a 1, so I won't even bother writing that. Now, before we solve, let's see what we got going on for restrictions. From here, we can't have x plus 1 equal to 0. So x cannot be equal to negative 1. X cannot be equal to negative 1. We've already accounted for that here. This guy could also cause a problem. X minus 1 cannot equal 0. So x cannot equal positive 1. So negative 1 and positive 1 are no-nos. And we don't have any x's in here to worry about. So those are the only two restrictions we have. So hopefully we solve this and neither one of those is our answer. All right, let's bring everybody up to speed for the denominators. So for the LCD, this first fraction is only missing the x minus 1 part. This fraction isn't missing anything. This fraction is missing everything, right? X plus 1 and x minus 1, both top and bottom. All right, once I do all this multiplying on the bottom, my fractions will be up to speed. So I'm not going to bother rewriting that LCD. I know they're all up to speed with the purple. So I'm just going to write the top and solve the top. So this first part is I've got a 3x being multiplied by x minus 1 equals a 12 plus a 2 times x plus 1, x minus 1. Now, let's distribute and combine like terms and see what we're working with here. I've got a 3x squared minus 3x equals 12 plus 2 times, we know that this FOILed together is x squared minus 1, right? X times x times negative 1, x times positive 1, and 1 times negative 1. So that's what that is. Simplifying further, and I'm also going to move things over to one side. So 3x squared minus 3x minus 12. I'm going to move everything over here. This will be distributed into here, so it'll be 2x squared minus 2. So I'm going to subtract negative 2x squared plus 2 equals 0. So I've got all this stuff over here and a 0 over here. So let's combine like terms. That's 1x squared minus 3x minus 10 equal to 0. So instead of a linear, like I had up here to solve, I've got a quadratic that I need to solve. How do I solve quadratics? I have a couple of tools in my bag of tricks. I have factoring and solving, I have completing the square, I have quadratic formula. The easiest being factoring and solving. So let's see if we can factor this. Is there anything that multiplies to negative 10 and adds to negative 3? I found 5 and 2. What kind of 5 and 2? A negative 5 and a positive 2. So now that I've factored that, I can solve each of these. X minus 5 equals 0, so x equals 5. X plus 2 equals 0, so x equals negative 2. Check real quick to make sure I don't have two answers that are listed up here. Nope, I see neither of them listed here, so I'm allowed to say my answers are 5 and negative 2. So keep those quadratic solving skills handy for solving these as well. All right, number 5. Once again, I'm confronted with a problem that probably needs a denominator factored before I can get a clear picture of what the LCD is. So this doesn't need to be factored, this doesn't need to be factored. Let's look at this one here. What multiplies to negative 10 and adds to positive 3? Probably another combination of 5 and 2. This time it's a plus 5 and a minus 2. Okay, so that's now my denominator going on this fraction. If I look across the bottom, clearly my LCD is going to be x minus 2 and x plus 5. My restrictions, I can't have x being 2, because if it was, that would cause a 0 here. So x cannot equal 2. And I can't have an x being equal to negative 5, because that would cause a 0 there as well. So negative 5. So 2 and negative 5 are no-nos for this particular problem. Let's get everybody up to speed for the denominators. This fraction is missing the x plus 5, So let's give both top and bottom x plus 5. This fraction is also missing x plus 5. So let's do that to both the top and bottom. This fraction is not missing anything from the LCD, so it doesn't need to be multiplied by anything. Now that we have the orange actions being taken across the board, we no longer need our denominators. We just need to solve the top. So let's rewrite the top so that we can solve it. If at any point you don't understand why I've written the top as I have, go ahead and pause the video and stare at it, make sure that you know where these are coming from. So once I have my common denominator, I can just solve the top, solve the numerators, and make sure that you check all the signs. Alright, let's distribute and combine like terms. 2x plus 10 equals x squared plus 5x plus 6. I'm going to combine everybody on the right just because I like positive things. So x squared, I'm going to subtract 2x from both sides. I'm going to subtract 10 from both sides. So let's now factor this if we can. Hopefully we can. Anything that multiplies to negative 4 and adds to positive 3, probably some combination of 4 and 1, and that 4 needs to be positive and the 1 needs to be negative. So now I can solve this. Since I could factor it, I didn't need the quadratic formula. X plus 4 equals 0, so x must equal negative 4. X minus 1 equals 0, so x must equal positive 1. I checked both of these answers against my restrictions. Neither one of them is on the list, so I'm okay to write x equal negative 4 and 1 as my two final answers for this. Both answers need to be included to be complete. Let's take a look at 6. When I look at 6, first of all, I need to make sure that I see this negative sign here, so don't forget that when we're solving. This has a denominator of x. This has a denominator of x plus 1. This denominator needs to be factored. This is not a difference of squares. This is not a sum of cubes. This is not one of our special cases. You need to see that we have a greatest common factor here, a GCF. There's an x present in both of these terms. So we need to factor that out and leave x plus 1 behind. Make sure that you can see that when you come upon denominators that look like this. So this denominator can be rewritten as x times x plus 1. So now I look across the bottoms and I try to figure out what's my lowest common denominator. It appears that I can account for my lowest common denominator by having an x and an x plus 1. That will take care of everybody. So let's see who's missing what. This first fraction has everything. This second fraction is missing an x. And the last fraction is missing the x plus 1 part. So now that I have all of the denominators matching, I can throw them away and solve the top. Signs matter. So 3 plus 3x equals negative 1 times x plus 1. Remember, these are all multiplying actions. Let's combine like terms. So 3 plus 3x equals negative x minus 1. Let's add x to both sides. Let's subtract 3 from both sides. And we have x equals negative 1. Now, I forgot to come up here and make sure I wrote my restrictions. So before I write my answer here, let's make sure that we account for our restrictions. What could we not have in the denominator here? Hopefully you're ahead of the game here for me. You've already seen that you can't have x equal to 0. That would be a no-no. So x cannot equal 0, right? And also x cannot equal negative 1. So that would be a problem. If x was negative 1 here, you'd cause division by 0. So those were our restrictions. My apologies for not doing that first. So now let's see. Our final answer on here was x equal negative 1. But what we just saw was that we had a restriction against negative 1. And so once again, we have no solution. If your only answer is on the restrictions list, you don't have a solution. All right, let's take a look at 7. 7 is interesting. We have one fraction set equal to one fraction. Let's list our restrictions before we forget again. So let's see, this set equal to 0 can't be equal to 0. So we must be able to say x cannot be 4. X cannot be 4. And this fraction isn't really causing us a problem, right? There's no x's down here that could cause a division by 0. So our lowest common denominator, looking at the bottom here, appears to be 5 times x minus 4. Now, when you have this special case of one fraction equal to one fraction, you have a couple of different options. You could continue down the path of bringing both up to speed, bringing this denominator up to speed by multiplying by a 5 over 5, and this denominator up to speed by multiplying by x minus 4 over x minus 4. That will get you the answer just the same. But you could also say, since we have one fraction equal one fraction, you could cross multiply to solve this one. Both methods are completely fine. I'll just, for the sake of showing this method, I will do cross multiplying. Please remember, this is only a possibility if you have one fraction equal to one fraction. Down here, that's not an option. We have fraction plus fraction equals fraction. But when you have one fraction equal to one fraction, you're allowed to cross multiply. So I have x minus 4 times x plus 5, that's this cross, equals 2 times 5, which is 10. FOIL this out, so x squared plus 5x minus 4x, that's plus 1x, minus 20. Let me subtract 10 from both sides, equals 0. So I've got an x squared plus x minus 30 equals 0. Hopefully I can factor this so that I can come up with my two answers to this quadratic. Multiplies to negative 30, adds to 1. It must be some combo of 6 and 5. And the 6 must be positive and the 5 must be negative. So if I have x plus 6 equals 0, I must have an answer of x equals negative 6. X minus 5 equal to 0, I must have an x equals 5. I check to make sure I don't have anything against the restrictions. Neither of these is a restriction, so I put both as my answer, x equals negative 6 and 5. And again, we can only cross multiply if we have one fraction equal to one fraction. Otherwise, we're bringing everybody up to the LCD. So let's take a look at number 8, where we don't have that situation and we do have to bring everybody up to the lowest common denominator. Let's see what these denominators have in store for us. So a lot of this needs to be factored. So let's see this as the difference of squares that it is. X plus 3, x minus 3. So that's what I have here. Sorry about that. And then this second fraction must have to factor this. So what multiplies to negative 15 and adds to negative 2? It must be some combo of 5 and 3, and the 5 needs to be negative and the 3 needs to be positive. And then this last fraction, I am once again looking at a difference of squares. So it must be factored to x plus 5 and x minus 5. So I've got quite the lowest common denominator here, right? If I'm looking across here, it looks like I have x plus 3, x minus 3, x plus 5, x minus 5. That's what I would need to account for all of these different factors here on the bottom. Restrictions. If any of these factors was set equal to 0, I would cause division by 0. So x may not be any of the 3's, right? Can't be negative 3 here, can't be positive 3 here, it can't be positive 5 here, it can't be negative 5 here. So x cannot be positive or negative 3, positive or negative 5. So if any of those are my answer, positive or negative 3, positive or negative 5, I need to take those off the list of my answers. So now let's make sure that we can bring everybody up to speed. Instead of cramming that up here, I'm just going to rewrite these down here. So originally I had a 2, and to bring the orange up to speed, I would need to multiply by x plus 5, x minus 5. That's what the orange is missing. Then I have this 1 sitting on top of red. The red is missing an x plus 5 and an x minus 3. Then I have a 4 sitting on top here, and the blue is missing x plus 3 and x minus 3 out of our denominator. So once all the tops and bottoms are brought up to speed, I can solve the top. This is quite a bit of work, so take your time and use extreme attention to detail. Let's see, I'm going to call this, since I know what this is the same thing as x squared minus 25. I'm going to think of that like that. And I'm going to think of this as x squared minus 9, just because that'll make distributing these numbers in here a little bit easier. So let's treat this first one as 2x squared minus 50. Then let's FOIL this together and say that's x squared minus 3x plus 5x, so that nets us 2x, minus 15. And then let's distribute this 4 over here. 4x squared minus 36. So we need to collect all of our x squareds, all of our x's, and all of our constants all on one side and put a 0 on the other, because we've got another quadratic to solve here. So let's do that now. It looks like I've got 2 of them, 1 of them, 4 of them, so I'm going to move everybody to the right just so I have stuff that's positive. So 2x squared plus 1x squared, that's 3x squared. Subtract 3x squared from both sides, and I have 1x squared left. X terms, it appears I've only got one of them. I've got this 2x here. So subtract 2x from both sides. Constants, I have negative 65 on this side and negative 36 on this side. So to counteract the negative 65 over here, I'll add 65 to both sides. So when I add 65 to both sides, I have plus 29. And after subtracting everything from this side, I'm left with nothing over here. Now, anything that multiplies to 29 and adds to negative 2, we know 29 is not factorable, right? There's nothing, I'm sitting here thinking what could possibly multiply to 29 and add to negative 2. There isn't anything. This 29 isn't divisible by any whole numbers. So what are my tools? What's my remaining tool? If I can't factor and set the factors equal to 0, how do I solve this quadratic? I solve it using the quadratic formula. Okay, if you can't factor and set the factors equal to 0, you must solve with quadratic formula. And we already know that if we're stuck doing that, there's no way that we're going to have a 3, a negative 3, a 5, or a negative 5. So I'm 100% very, very confident that I'm not going to have an answer that breaks any of the restriction rules. So let's go ahead and do that little step here. Quadratic formula. Negative b plus and minus the square root of b squared minus 4ac over 2a. That gets me down to 2 plus and minus the square root of 4 minus 116 over 2. This gets me down to 2 plus and minus the square root of negative 112 over 2. And the last little simplification, I try to pull perfect squares out. I definitely need to pull this I out of here, the square root of negative 1. I found a 16 in here, so I'm going to write this as 2 plus and minus 4i times the square root of 7 over 2. Sorry for the small writing. Again, I pulled the square root of 16 out of 112 and made it a 4. 112 divided by 16 left the 7 behind. And again, I pulled an I out. So the last little step I would do here is do a little bit of simplification. This 2 is present in all 3 places. So take a 2 out of here and leave a 1, a 2 out of here and leave a 1, a 2 out of here and leave a 2. So my answer is x equals 1 plus and minus 2i times the square root of 7, which clearly doesn't break either of these restrictions, okay? So again, hopefully we can get down to a quadratic that can be factored and solved easily, but sometimes if you can't get there, if you've got nasty numbers like this, you're stuck using quadratic formula to get the precise answers, okay? All right. Go ahead and attempt your independent practice and let your teacher know if you have any questions.